All right, let's go over the rational root theorem where we got to find our possible candidates for roots to this given function. Okay, one thing I want you to be aware of though is right away you should recognize if you are dealing with rational root theorem, you've seen enough polynomial functions to know that when you see this, something should really stand out, right? Like something looks bizarre, something looks a little weird. It's not in the order we want it in, and that could cause some major issues when trying to do the rational root theorem because we need a leading term and we need a constant at the end. If I go to my ending term here, this is by no means is a constant. 23 is my constant, plus 23. So that's what I want over here at the end. And then I actually should have this term of 2x cubed. That should be my leading term in the front because it's got the highest exponent. Okay, so what you would do is with a problem like this, hopefully you recognize right away that they have not put this in what's called standard form. So step one, I'd rearrange some things. I would say, let's bring the highest exponent to the front. So my leading coefficient now is 2. And then I'm going to look and say which one's my second term. X to the power of 2 would be the next one. So minus 15x squared. Minus 15x squared gets written down. Then I've got the x term without the exponent of 1 being shown, so negative 25x. And then we take that constant, just that regular good old-fashioned number, 23, and we put it at the end. So if you look now, my exponents are going in what's called descending order. Highest is 3, down to 2, 1, we don't show it, and then there is no x, so it's a constant, it's just a good old-fashioned number. So the rational root theorem comes into play now. We go to our ending term, in this case, this constant of 23, and then our leading coefficient, which would be 2. The ending constant term is going to have to do with your numerators for your roots. Your leading coefficient has to do with your denominators. So, top number, bottom number, make it simple. Okay, we take 23. You always take the ending constant. I like to write it down. The way I'm going to show you to do this is using a table to organize your information. I don't need to go that long with my line because I only have 2 factors of 23. 23 can only be divided by a positive or negative 1 and a positive or negative 23. So there's only 2 options there, meaning I'm going to have 2 columns. Then I'm going to go down like this. And I'm going to take my leading coefficient value. So I took 23, I found its factors, I listed them out. Now I'm taking the leading coefficient, 2, writing it down over here on the side, and then I need to give its factors. Well, 2 also only has 2 factors, positive and negative 1, positive and negative 2. So we go like this, and now it's just a matter of taking this factor over that factor, numerators over denominators. So that'd be like taking this and going, oh, it's 1 over 1. But we all know 1 over 1 is just 1. So when we take this over that, we're going to get positive or negative 1. 23 over 1 would give me positive or negative 23. Why? Because 23 divided by 1 is just 23. Now we're taking 1 over 2. Hey, 1/2, so positive or negative 1/2. And then we're taking 23 over 2, which is not going to come out nice and neat, so I'm just going to keep it as my fraction of 23 over 2. Positive or negative 23 halves. Okay, I look at each one of them. None of these duplicate, so we have 8 potential, positive and negative each, there's 4, so 8 potential rational roots to this function. All right. How would you answer this? You can leave it like that. I prefer that my students go and list them out in order. So start with the smallest one, positive or negative 1/2, comma, positive or negative 1, comma, 23 halves, positive or negative 23 halves, and then last but not least, the biggest value, positive or negative 23. There are your possible rational roots to the given function. Hopefully this makes sense. Study hard and good luck on your upcoming test.